Hello guys, good day. This will be a recorded lecture for us to compensate doon sa mga meetings natin na we are unable to have a synchronous meeting. So our discussion for today is about still digital circuits, which is broken down into two. We have combinational circuit and sequential circuit. Okay, so this will be our remaining topic for the finals. We will discuss about combinational circuit and sequential circuit. For combinational circuit, as a summary, if we say combinational circuit, the output is only depending on the present input. Ibig sabihin, kung ano yung input mo, it will determine what will be the output. Compared to sequential circuit, pag sinabi naman nating sequential circuit, the output is depending on the present input and the past output. Ibig sabihin, yung previous state niya plus yung input ngayon will determine the output. So, yun ang pinagkaiba ni combinational compared kay sequential. Another thing is, in combinational circuit, we do not have feedback and we do not use memory. So, walang feedback, walang memory. But for sequential circuit, since nasabi natin kanina that the output is dependent on the present input and the past output, that means that there is a feedback and there is a memory being used. Kasi nga, kailangan natin yung past output which is stored in our memory or which is being feedback pabalik doon sa ating sequential circuit. So, for combinational circuits, we have examples here such as the half adder, full adder. We have half subtractor, full subtractor. We have multiplexer, demultiplexer, encoder, decoder, and we have your code converter. Or in sequential circuit naman, we have your counter, shift register, and flip-flop. So we will discuss these examples as we go on. For now, unahin natin si combinational circuit. In combinational circuit, we have 4 steps in designing the combinational circuit, which is the first step is to determine and define the total numbers of inputs and total number of outputs of the circuit. So, aalamin natin dyan kung ilan ba yung magiging input natin at ilan ba yung ina-expect natin na magiging output. For step 2, we will make the truth table, which is ginagawa na natin with our previous lessons. This truth table will define the relationship between inputs and outputs. So, for step 3, we have to determine the Boolean expression using K-map or Karnaugh map. So, you already know that. It is explained and discussed with our previous lessons. So after that, we have determined the Boolean expression using our K-map. We can now proceed to the step 4, which is to form the circuit itself, based of course from the Boolean expression. So bear in mind, itong 4 na steps na to ang susundin natin to deal with our next topic, which is the half-adder circuit. So, as I've said, half-adder circuit is an example of a combinational circuit. So, pag sinabing half-adder, ang tatandaan lang natin is this performs 2-bit addition. Okay, so addition ang ginagawa nito, kaya nga adder. Where we have A and B as the inputs and S and C as the output. Ibig sabihin, A and B ang input natin, S which is equal to sum, and C, which means carry over ang magiging output natin. So, for step 1, pag i-determine natin yung total inputs and outputs, our answer will be, there are two inputs, A and B, and there are two outputs, S, sum, and C, which is carry over. So, ganun lang kasimple yung step 1 natin. So, let's proceed to step 2. For step 2, we are going to make the truth table. So, for truth table, since alam natin yung number of inputs natin, we could now create the possible combinations. So, here is our truth table. So, we have A as an input, B as an input, S will be our output, and C will be also our output. So, ang pattern lang dyan is 0, 0, 1, 1 and 0, 1, 0, 1. Since we are talking of half adder, we are going to add input A and input B. So, again, 0 plus 0 will give us a sum of 0. And of course, walang carry over. That will be 0. Another is input A is 0 plus input B is 1. 0 plus 1 is 1. Then wala din tayong carry over. So that will be 0. 1 plus 0 naman will be 1. Wala din tayong carry over. If you notice, naka-highlight yung last row natin because 1 plus 1 is 0. Okay, 0 carry 1. So, ito yung silbi ng carry. Kasi pag pinag-add natin yung 1 and 1, as discussed on our first lessons dun sa number systems natin, 1 plus 1 is 0, carry 1. So, ilalagay natin yung carry dito. Now, if we're going to take a look, anong gate ba, anong logic gate ba ang ginagamit to add to perform the addition operation? That will be your OR gate. Okay? As we have discussed doon sa mga logic gates natin, OR gate is responsible for the process of addition. But you have to take note that dito, 1 plus 1 is 0, which is hindi na siya characteristic ng OR gate. Instead, this is an example of XOR gate or not OR gate. Okay? So, you may want to review yung truth table ng XOR gate natin. Okay? So, ang ginagamit natin sa half adder is XOR gate, not OR gate. So, since alam na natin yung truth table, pwede ko nang gawin yung K-map natin or Karnaugh map, which is step 3. So, ang gagawin lang natin is, I'm going to create a K-map for S or sum. So, ito siya. So, imamap out ko lang yung truth table ko. Dito, this will be the corresponding truth K-map. We have A and B. The possible values are 0 and 1. Same for B, 0 and 1. So, ang 1 dyan is, magwa 1 yung output natin if A is 0 and B is 1. So, ito siya. Another is if A is 1 and B is 0. So, as you can see, with this K-map, I can now derive the Boolean expression, which is etong unang grouping natin that is equivalent to A, B bar. And yung second grouping natin, that is A bar or A complement times B. So, I can now create the Boolean expression for my sum or S, which is equivalent to A complement B plus A B complement. Now, if you're going to research or review yung XOR gate natin, if you see this pattern, you can simplify it as A XOR B. So, Sabi ko nga kanina, it's hindi OR gate yung ginagamit natin, it's XOR gate. And meron tayong simplification sa XOR gate na pag ganitong pattern ang nakita natin, that is also equivalent to A XOR B. Okay? That is our K-map for sum. Ngayon, you need to do also the K-map for carry. Okay, so sa truth table kasi natin, andito yung carry natin. So, ganun din, same as the sum, gagawa tayo ng K-map for carry. Ipa-plot ko lang yung nasa truth table. So, iisa lang ang 1, if you notice. Nag-1 lang yung carry natin if both A and B are equivalent to 1. So, andito siya, where A is equal to 1. B is also equal to 1. Ito siya. So, my Boolean expression for carry is C is equal to AB. So, we are now done with step 3. Isang step na lang, which is step 4. We will now draw or create the circuit based from our Boolean expression where S is A XOR B and C is equal to AB. So, the answer is, since XOR gate, this is the symbol for XOR gate, ito siya. And since carry is equal to AB, so A times B, ang gagamitin natin is an AND gate. Kasi pag multiplication, AND gate ang ginagamit natin. So, by drawing it, ito yung equivalent circuit natin ng half adder. A XOR B is equal to S, and A times B is equal to C. Just take note na pag nagdodrawing tayo, yung A papunta kay AND gate, hindi dapat siya nagtatouch doon sa line ni input B. So, this is our circuit for the half adder. So, kung may tinatawag tayong half adder, may tinatawag din tayong full adder. Si full adder naman, it performs 3-bit addition. Okay, so 3-bit addition. From half adder, magdadagdag lang tayo ng isang input, which is C, para maging 3-bit addition siya. Still, dalawa pa din yung kanyang output. We have sum and our carryover. So, ang gagawin lang natin is to repeat the steps from step 1 to step 4. So, let's proceed. For step 1, we are going to determine and define the total numbers of inputs and output. So, sabi ko nga kanina sa half adder, we only have 2 inputs. Ngayon, kay full adder, we have 3. So, tatlo na yung inputs natin. A, B, and C. Then, still, yung number of outputs natin is dalawa pa din. Si sum and carryover. Now, we can now create the truth table. So, that is step 2. Since tatlo na yung input natin, magbabago na yung ating pattern. So, this will be input A, input B, and input C. Still, we have our sum, output, and carryover as output. So, notice we have 4 zeros, 4 ones, followed by 2 zeros, and 2 ones, then alternate na 0 and 1. So, since this is full adder, the same pa din yung operation natin na ginagamit. It's addition. So, proceed. 0 plus 0 plus 0 is 0. Ganun pa din, wala tayong carryover. So, that will be 0. 0 plus 0 plus 1 is equivalent to 1. Wala pa din carryover. We have 0 plus 1 plus 0 is 1. Still, walang carryover. Then, 0 plus 1 plus 1. So, 1 plus 1 is 0. Carry 1. So, sa carryover natin, maglalagay tayo ng 1. Another 1 plus 0 is equivalent to 1. Wala tayong carry over. Still sa next row, 1 plus 0 is 1. Plus 1 will be 0 carry 1. 1 plus 1 is 0, plus 0 will be 0 carry 1. And dito, 1 plus 1 is 0 carry 1. Ito, lagay mo yan. Then, 0 plus 1 will give you 1. So, this is our truth table for a 3-input full adder. Okay? So, step 3, we're going to determine the Boolean expression using our K-map. Ganun pa din. Since tatlo na yung inputs natin, pinagsama ko si AB, then nakaseparate si C, wherein AB has the possible values 0, 0, 0, 1, 1, 1, and 1, 0. For C naman, we have 0 and 1. So, if we're going to map out this truth table sa ating K-map, we will arrive at a pattern wherein ganito yung position of ones natin. Yung mga naka-encircle ng blue. So, if we're going to generate the Boolean expression, that will be our sum is equivalent to AB bar C plus A bar B C bar plus ABC plus A BC bar. When I say bar, it's the same with complement. Okay? So, ang tawag dito sa pattern na to is your checkboard algorithm. Again, since you may want to check kung anong ibig sabihin ng checkboard algorithm, but in simplifying this Boolean expression, since we are using XOR gate ulit, that will be equivalent to S is equal to A XOR B XOR C. The same with our carryover, i-map out lang natin yung truth table natin. Okay, so always remember in K-map, we select the largest possible groupings. So in our case, we have 3 groupings here. Okay, so we have the output as the carryover is equal to BC plus AC plus AB. So this will be our Boolean expression for carryover. So BC is at this one, this grouping. This is BC. We also have AC. Ito siya yung nasa gitna. And AB is yung nasa dulo. Okay, so for your activity in this lesson, we're going to draw the circuit based from the Boolean expression from step 3. So you are going to draw the corresponding Boolean expressions or the circuit for these 2 Boolean expression. So as a reference, pwede ninyong balikan yung half adder natin, which is ganito yung output. So since magkaiba yung na-derive natin na Boolean expression for half adder and full adder, ibig sabihin, ibang circuit din ang madederive ninyo if you're going to create the circuit for these Boolean expressions. So that is half adder and the full adder. So for sample application ng half adder and full adder circuit natin, I would like to emphasize yung sinasabi ko kanina, pag half adder, 2-bit value ang ina-add natin. So the minimum, yung possible na i-add natin is 2 bits lang. So that will be from 00 to 11 kasi nga 2 bits lang. Okay? So in itong binary digit na to, in decimal, that will be this is 0, and if you convert it into decimal, etong 11 is equivalent to 3. So if you're going to use the half adder, ang pwede mo lang i-add is from 0 to 3. But for 3-bit value, okay, so 3-bit value, eto tayo, 0, 0, 0 until 1, 1, 1, where ito nga yung breakdown. We could add decimal numbers from 0, 1 to 7. So let us have an example. We are going to generate a truth table, came up for sum and carry over, and the equivalent circuit diagram of the Boolean expression S is equal to A plus B, where A is equal to 2 and B is equal to 3. So for the solution, ko-convert lang natin yung value ni A, which is 2, into its binary equivalent. So that will be 0, 1, 0. Yung value ni B, which is 3, into binary equivalent, that is 0, 1, 1. And we're going to proceed from step 1 to step 4. Okay? So step 1, determine the number of inputs and outputs. So there are 2 inputs, A and B, and there are 2 outputs, your sum and carry over. Then we are going to proceed with the truth table. So imamap out lang natin. So we have 2 inputs, A and B, 2 outputs, sum and carry over. So if you notice, yung value ni A, input A, 0, 1, 0. So sinulat ko lang siya, 0, 1, 0. And the value of B is 0, 1, 1. That will be 0, 1, 1. Okay, so pag in-add natin siya, that will be 0 plus 1 will give you 1. Tapos wala siyang carry, so 1 plus 1 will be 0, carry 1. Then yung carry na sinasabi natin, ililipat lang natin siya dito. Kasi nga carry over. So yung carry natin, ililipat natin siya dito, carry over. Then 1 plus 0 plus 0 will give you 1. And wala tayong carry over, so 0 ang ilalagay natin dito. Okay? So now, ang magiging sagot dyan is, of course, 2 plus 3 will give us 5. So if you're going to interpret this one, 101 in its decimal equivalent, that will be 4 plus 1, which is equivalent to 5. Okay, so for step 3, came up for sum and carry over. Ipa-plot lang natin yung ating tawag dito, truth table. So this will be the output, wherein we could now derive the Boolean expression for sum, which is A bar or A complement. So hindi natin sinali si B kasi nag-change siya ng value. Naging A complement siya because nagiging 1 yung output if A is 0. For our carry over naman, we have the output as C is equal to AB. So for your second activity, we're going to draw the equivalent circuit of the Boolean expression for sum and for carry.